Okay, thank you everybody for signing in today. This is one of OneSpatial's Fme training webinars. We're running a series of training webinars and have been throughout the last few months. A number of sessions have already been covered, and we have a schedule going up of revised sessions in the forthcoming months. My name is David Eagle, and I'm a principal consultant at OneSpatial, and I'm going to be focusing on the Fme product set this month, looking at how to make the most of data.gov.uk and also open data. So there's a number of topics to discuss around that set of capabilities, and we'll be looking at it in the context of using and maximising your investment in the Fme product. So these are free training sessions to be able to dial into. We have a number of topics that we're going to cover throughout this session, looking initially at some of the open data initiatives that are out there, where you can go and discover more information about the data that's available, as well as different local authorities, different national government agencies that are making their data available in increasing volume. I often get asked in training about efficiency capabilities and tips and tricks to do with writing your Fme workbenches. I'm going to spend some time highlighting a few of those that I find extremely useful. Hopefully you'll be able to build some of these capabilities into your own workspaces. We're going to look at dealing with postcodes, but for all of the tips and tricks, I'm really just using postcodes as generally as a topic to discuss some of these capabilities around. So we're going to look at loading some open Ordnance Survey data into an Oracle database and look at how to work with spatially indexed formats so that we can be more efficient in the way that we read and write our data. We're going to look at how we can consume web services using Fme. People will be familiar with web services like a web map, a WMS, and also WFS, web feature services. We'll take a look at some of those. We'll also look at how you can work with carrying out geocoding processes using Fme. Some of that will lead us on to looking at some of the other Ordnance Survey open data sets, looking at particularly processes to create PDFs. And we're also going to spend a little bit of time looking at some of the linked data that is out there and accessible. And one case example I'm going to look at is the Environment Agency's bathing water quality data and how you can access that and read essentially XML published data directly into Fme. So a number of topics to take a look at today. The session will be roughly an hour long. I'm going to start with a very brief introduction to who we are, to brand new people that perhaps haven't dialed into these sessions before. Our business is called OneSpatial. We've been around for a number of years, since 1969, and we work with a number of different customers, be they local central government or national mapping agencies, and a number of organisations across the globe. Our focus as a business is around data quality and data, basically gaining data efficiencies. So we have a number of our own products that we build and create, and we also resell a number of products that fit our capabilities and our focus. One of those products that we work with is a product called Fme, and that comes from a vendor called Safe Software. They're a Vancouver-based business over in Canada on the west coast, and they really have forged a strong position for acting as essentially the middleman for your data, taking your data out of one repository and writing it into another. And that's really where Fme excels, both in translation but actually also in the manipulation and restructuring of your data, so that's transformation. Fme as a product sits very happily between all of the different vendors that you can see highlighted there. And previously in this webinar we've looked at specific sessions around working with Pitney Bowes software, MapInfo Professional. We've also looked at working with Autodesk, and no doubt we'll be focusing on some of the other environments at some point in the future to give you an overview. As a business, we have a number of capabilities in the FME arena. We both support and work with both products that Safe Software produce, that's FME Desktop and FME Server, and we have a significant number of certified staff now in the business, with 4 certified professionals and 3 trainers globally. And we provide a number of services around the FME product set, be that product evaluation, if you need assistance with setting up an FME environment, whatever that is, to get used to the product, then we can help you with that. And we also have formal training and consultancy packages to assist you once you've bought the software and want to get up and running quickly. And those training services complement these kinds of free sessions that we deliver through this webinar capability. I noticed from the subscription list this morning, and that has been passed to me, that we have a number of people who are new to FME on the call. So a very basic overview to begin with, just to highlight some of the capabilities of the product. FME is able to read and write over 270 different data formats. So it has a vast support for working with different data formats, be they raster or vector, non-spatial or spatial, database or flat files, 3D, 2D, XML, you name it. FME has support for a significant number of different data types. And it can understand the structure and the capability of those data sets. So it is very much an interoperability tool that you can use within your organization. I often hear it referred to as a Swiss Army knife, in fact. When you buy FME, you have access to a number of different tools, and these are just summarized very briefly here. FME Workbench is something you're going to see a lot of here. FME Workbench allows you to essentially write code without having to write a line of code. You have a drag and drop interface that allows you to connect features or capabilities that carry out tasks on your data. You can view all of your data without having to translate it using the Universal Viewer and the Data Inspector. You can carry out quick translation with a very simple tool that allows you to specify where your data is and where you want it to go and what format, and just push go and write the data out. And you also have the ability to extend FME, your FME license, into other products like those from Autodesk, Pitney Bowes, and also from ESRI or Esri as well. So a number of different products all bundled up into that FME desktop product. So for this session, now I've got the summary out of the way, you will notice at several points those blue slides splitting up sessions, giving you opportunity to take stock of what we've covered, and there will be room for questions throughout. So as this is an online training session, feel free to put messages into the chat window, and they will be relayed to me so I can try and address those in the session. We will hold on at the end of the session as well, so that if you wish, you can dial in or dial any of your questions into the chat window and send them over to us at the end. And we'll cover those off as a close. So I'm going to focus initially on some open data initiatives, and I wanted to highlight a few that may already be familiar to you, some that might not, and hopefully you'll be able to go out and discover a few more as a result of this session. There's lots of sources of open data available to get access to, and there are a number of data hubs to go and take a look at. The one I'm going to focus on initially is the data.gov website. It actually received a bit of a revamp earlier this year, but it's been around since 2010. So if we just pop that open, you can see in here that this is a discovery portal that allows you to go and find different data sets And you can go and have a look at all the publishers, for example. So we could go and have a look at somebody like the Ordnance Survey, and you can see that the Ordnance Survey are listed here, and it details all of the products that are available from them, some of which are open data, some are licensed. So for example, if we go to CodePoint, we can go and have a look, a little bit of the detail. It gives you some information about the extents of the data, as well as the lat long, or the bounding box, and the resource locator to go and be able to download the data. It links us straight to the relevant website, so we can find out how we can buy the data, or if the data is open data, then if we go to something like CodePoint Open, we can see that there is an ordering page that allows us to basically go across and have access to the data. So we can see that we can locate the resource, and here, because this is open data, we can go and order it as a download, or as a CD or DVD. So that's just a way of discovering data. You'll find that you can while away quite a bit of time looking at data.gov. There is a lot of data to go and discover. And towards the end of the session, we'll touch also on linked data. So if we just make our way back, data.gov itself, rather than .gov.uk, is I guess the US version of the capability. So again, a lot of data available on data.gov, and that has also been around for some time. So really, we're in the UK making the most of the organisation's data that we have out there, and allowing people to discover that. Another hub that it's interesting to know about is Geostorm, that is a collaboration with from the Environment Agency, that collaborates with some of these organisations that you can see listed here. So Natural England, English Heritage, Forestry Commission, DEFRA, and the Canal and Rivers Trust. So a number of data sets are available to discover and download, but more interestingly, I think there are web services available as well, so both web map and web feature services. You do need to register an account with the Geostorm, but there are licensing terms and conditions that you can read and subscribe to, and if you do that, then you can get access to a number of the different data sets free of charge through this data store. So certainly, if you're interested in things like sites of special scientific interest, and maybe heritage buildings, those sorts of features are the types of data sets that are available as web services for you to consume in your GIS, or even just consume with Fme and translate into a local data set if that's what you'd like to do. Local authorities out there that are starting to put data and make that available. There's a couple of examples there in the UK. Warwickshire and Nottingham are both doing a sterling job of making data available. Both organisations use Fme behind the scenes to process their data and look at making that available through those different portals. And also the City of Vancouver has a data catalogue that goes one step further, and that is that it allows you to create a number of different data sets and make them available in different formats, and serve them into web browsers using things like Google Maps and Bing Maps behind the scenes. They also have the City of Vancouver also has a mapping interface from which you can request data. So that actually utilises the Fme server product that State Software also make. Open data products, I've already alluded and touched on the Ordnance Survey's data. You can obviously, rather than just directly browsing to data.gov, you can go direct to the Ordnance Survey's open data site and go and take a look at the data sets that are available to you, a number of which can be ordered, and I'll touch on those in a little bit more detail in a moment. But there's also Openstreetmap, and it's increasingly a data set that people are considering using. Openstreetmap.org takes you to the international site that has a number of different coverages covering the globe. So we're zooming into France there, and I'll just pan back out again and dive into Oxfordshire, and we can make our way. And you can see that this is a web service that refreshes. So that's something that's quite interesting. Interesting for people in the UK is Openstreetmapgb.org. This is a collaborative site that it's useful to go and have a look at, and I'll talk more about that in a moment, so I'll leave that URL up there for a moment. That's osmgb.org.uk. I'll just drag that out of the way, and we'll cover that in a bit more detail in a moment. So Ordnance Survey open data products that are available. There's an assortment of formats available, and there's 11 products, although I believe there's actually 12 unique products that you can download, because OS Vector Map District, shortly after its release, was also created as a raster product, so there is a raster version of Vector Map District. A little irony in the naming convention, but not one to worry about because it's open data, and the raster product is an exceptional product to take a look at. The data has been available since April the 1st in 2010, and as I say, raster data sets are available in a format like TIFF, and there's also some shape files and drawing exchange files, AutoCAD DXF data, as well as some digital terrain models. And Fme supports consuming all of those formats as well as many others, so you can use Fme to merge and conflate, geocode, translate, refresh, process any of those Ordnance Survey data sets as well. When it comes to OpenStreetMap, it's worth just highlighting that the GB instance of this is actually a collaborative project that we've got involved in with a number of organisations and a number of individuals, like Surrey Heath Borough Council, who originally helped conceive the idea, James Rutter, and we also worked with Stephen Feldman from Nowhere Consulting, and we've collaborated with Nottingham University, who host the data. And this is really a project that is attempting to deliver a number of things, notably essentially a QA stamp of approval to the OpenStreetMap data, as well as reprojected data. One thing that restricts take-up of OpenStreetMap in the UK is the fact that local authorities or organisations have to do some work to the data beforehand to reproject it into British National Grid or EPSG 27700, because it's natively hosted in that long. You would like, ideally, to consume a web service of the data directly into British National Grid, and we also run the GB instance of the data through our own technology to apply a number of rules to make sure that features snap together, so that some of the data quality issues that may be in the source data are removed from this instance, so that you can have a greater air of reliability around the data set. So that's another thing to be aware of, and you'll see in a short while the ability to consume that using Fme. So just a little bit then about some of the initiatives that are out there at the moment. What I'm going to do now is highlight to you just some of the tips that I'm going to be covering in the live demonstration aspect of this session. So I'm going to mention some of the capabilities to begin with, and then we will drill down into specific workbenches that include some of these capabilities. And the whole idea with a lot of the demonstrations that I give is that what we're trying to do is achieve flexible workspaces, workspaces that you can apply to a number of different data sets where possible, and try and use or reuse functions that you build to carry out specific tasks. One of the main things to put in place with your Fme Workspaces is to try and use a little bit of best practice to bookmark and annotate your workflows, so that users can understand in a few weeks or a few months' time exactly what you were trying to achieve in your workflow. Or even if you look at it yourself, you can understand what you've been doing. There is also a couple of capabilities on input and output. So on input, you can merge feature types. So a feature type in Fme is essentially a layer of data. And you can use Fme to ignore the name of the layer and just read the data into the workflow. And that's very important when you have, say, a database or ever-changing file names or layer names in your data sets. And you need to be able to have a workspace that doesn't care what the layer or the table is called. That's very useful when you want to create generic data cleanse or validation routines. So the capability to be aware of there is merging feature types, and I'll use the terminology that you would find in Fme. And also on the output, there is the ability to fan out. Fanning out allows you to specify a particular attribute that will either help you create multiple files, multiple layers, or multiple folders on your output based on that attribute. So if you had a lamppost data set, a lighting column data set, and some were made of concrete and some were made of metal, but all of that data was stored in one table, you could fan out on the destination on material type, and you would end up with, in that example, two tables or two layers of data, one containing all of the concrete lampposts and one containing all of the metal lampposts or lighting columns. We can also look at working with spatial envelopes. Using a spatial envelope is a very efficient way of reading data, especially out of spatially indexed data sets. And this is a capability that every format now has, but not all of them can utilize the speed efficiencies that you can get from a spatial envelope unless they are indexed. So we'll talk about indexing and searching spatial envelopes as well. Web services I've already referred to, Web Map and Web Feature Services. We'll see those in a little bit of detail. And we'll also take a look at working with PDFs as an output format. So I sometimes refer to a PDF as GIS Lite because you can write out into PDFs a number of different layers that you can turn on and off in Adobe Reader. You can also write 2D and 3D data into the layers, as well as the attributes that you can interrogate. So it's a very nice controlled way of supplying data to a user that is in its own right could almost be described as an interoperable format because many people have Adobe Reader available to them on their machines. And we're also going to look at working with XML, so we'll see that in a little bit of detail. Some of the transformations that you'll see utilize custom transformers. Now, a custom transformer is a construct in Fme that allows you to take one or more transformers that do a particular job and reuse those in different places in your workspace, or export them so that colleagues can use those custom transformers, or you could just use them to tidy up your workspace. So you'll see how that can be set up and defined in a short while. Lookup tables are also very useful. I tend to, in my training sessions, to mention lots of transformer names on purpose because finding transformers is a very useful capability, and working with transformers is very helpful in Fme. If I just go and navigate to a quick web page and show you that if we go to onespatial.com/Fme, and I'm just going to browse that page and then drag it onto the screen so you can see that. Grab it, there we go. So onespatial.com/Fme. If you go to the benefits tab on our Fme pages, when that refreshes, you'll see that if I clicked it, there we go. There is an option to download a Transformer Quick Reference Guide. I'd recommend that you get hold of this PDF if you're a new or even if you're an existing user of Fme, because this document lists in it all of the transformers that Fme 2012 supports, and it gives you all the names and all their capabilities and pictures about what they can do. Just take a look at some of those features, and it will really help your general day-to-day Fme use. I've just noticed we've got a couple of questions starting to come in. I'm just going to see if I can spot those. So we've got a question about, is Fme being used to populate data.gov.uk with datasets? Well, not specifically, but in some cases the data that is at the end of the link, it has been manipulated with or created or published with Fme. So a few examples that I'm aware of is organisations like Natural England and Countryside Council for Wales and the Environment Agency and a few local authorities are building data sets that they are populating or creating out of their databases, and they are extracting those and making a published set that they're prepared to deploy from their website or wherever it is that they're hosting that data. The other thing to bear in mind is that Fme does have capabilities around metadata. So some of the metadata that you can see, whether it's stored in Gemini 2.1 or stored in a more generic Inspire schema, that can be built using Fme. And if you take a look at YouTube and go and have a look at the Inspire session that I did previously, that will give you a little bit more detail about some of those capabilities. If you go and take a look at on YouTube, if you go and search for the channel One Spatial Group, you'll see a previous Fme webinar about Inspire that gives you a little bit more detail about some of those capabilities. Okay, so just back to this session. The focus that I was going to mention there was that transformers, there are many of them. There's over 400 transformers that give you different capabilities. The attribute value mapper is one of those, which allows you to create a lookup. So if you have a feature with a particular ID, a numeric value, which maps to a sensible value, perhaps somewhere in a spreadsheet, you can bring that value back and highlight, say, a planning application with an ID of 1. Well, that means that it passed. So you can populate that a string value in your data set with that value. Snapping processes you can use with Fme to map or snap to a base map, so you can read in portions of a data set using the anchored snapper and anchor a data set into a particular location. So for example, you wouldn't want to move master map, but you may want to specify that as your anchored layer and move your asset to that data set to snap to it. We'll have a look at things like writing Sql in Fme as well. So there's a number of Sql transformers that allow you to interact with the database. A useful one to take a look at is the Sql Executor, which gives you quite a bit of flexibility on how you query data. So if you're an Oracle or a database person and you're struggling to find the right transformer to carry out something in Fme, you can just execute some SQL rather than squeakle, some SQL and run that, and basically in the same way that you would in Oracle or in your database, you can run that directly using Fme and bring back features based on that query. There are also transformers that allow you to work with reading data partway through your process. The raster reader is one of those, and I'll highlight that in a little bit of detail. And one of the other things we'll cover is the test filter. So a number of changes have been made to testers in Fme. There is a tester and a test filter transformer, and those of you who have been on training sessions of mine or spoken to me in the past, or even if you've just looked at some of the stats on SACE's website, the tester transformer is historically the #1 used transformer in Fme. clearly it needed a bit of an overhaul, and in the last couple of versions some significant changes have been made to those transformers to make them very capable in the eyes of the everyday FME user. So just a little bit about some of the transformers that are available in FME and some of the things that we're going to be seeing. For the latter half of this session, we're going to focus on some live demonstrations, and we'll look at some approaches, different approaches to data transformation and also translation. So we're going to look at loading data into Oracle, working with spatial indexes, doing a little bit of geocoding, and working with some web services. So I'm just going to close down the slideshow and get that out of your way, and just take a look at a few workspaces or processes in FME to allow you to see what we're doing here. So if I go into a process first of all that looks at loading Oracle, so we'll open up a process. And this is it's not too big a workspace. You can see that that's not too detailed. There's a handful of transformers. Transformers are these blue and green things and cyan colored processes. And basically anything that is this blue color, this plain blue, light blue color here, this is a standard transformer that's available out of the box with FME. Some transformers you will see are green and some are cyan in color. These two transformers are custom transformers, and these have been built by an FME user. In this case, I've constructed these, but you may have built some for use in your organization. So they do have different capabilities. The green basically means that this transformer is embedded and available to this Fme Workspace alone, and this cyan color means that it's available to people who have access to FME in your organization, and that's perhaps a transformer that's stored on the network that multiple FME clients can see and can work with. So what we've got here in FME 2012 is the ability to open a containing folder, and what that does is open up the folder that stores all of the data, and here we have a little bit of this is code point open data that we've got access to. So I can just dive into one of these CSVs, open it up with Notepad, and we can see that we've got a postcode in here, and conveniently we have an X and a Y coordinate, as well as a series of codes. And those codes don't mean a lot to anybody until you join them to the data sets that they're supplied with. So if we go and have a look at the data, this is just the data that I've got supplied straight off the download or the CD, and you can see that there are some code lists. So there's an NHS code list. So one of the codes relates to the different PCT or SHA area, most of which will be fairly defunct fairly soon. So these boundaries and codes will have to be updated as the NHS changes over time. It's going through a significant transition at the moment. We can see that there's some code lists as well, and these code lists give us an indication of whether the postcode is to do with a type of authority area, and which county, which district, and ward those postcodes are in. So we can use FME to look up where I have a postcode in code point that has this value, does that, which ward does that appear within, and attach that to my data in the database. So essentially what my Fme process does is, as you can see, read in the source data as well as the NHS and the local authority code lists as individual readers. And you can see that they're listed here, the lookup tables at the bottom here. So they go into my custom transformer. Now in this process, what I've done is built a custom transformer to carry out a particular task. So to create a custom transformer, you select a transformer grouping and right-click on it and choose the option to create a custom transformer. And what that does is it gives you, in this instance, as you can see, a new tab inside which there are a series of relationships defined. So essentially in this process, all I've used a custom transformer for is to tidy up my top level view of this workflow. And you can see that if I want to, I can close that tab so that the individual user opening this up doesn't get distracted by that process. Or we can select it and choose to edit it, and now we can dive in and change any of the content here. So for example, if I wanted that NHS codes value there just to be that port name to be a singular, so I wanted to change that to NHS code, I can dive over and take a look at the input here and just go in and double click and change that to NHS code and dive back, and we can see that it has broken the link, but we just need to rejoin that, but now it's called NHS code instead, so it's directly connected. So all I need to do is just go and join that workflow together again so that we know that that routes through, and we've got our setup process there. So just changing and editing, diving back and rejoining. So all we've done with this custom transformer is tidy up our workflow and make the workspace a little bit less cluttered. If you want this transformer to be used by other individuals in your organization, you could go over to this tab here and you could basically go in and go to export this as a custom transformer. Exporting it as a custom transformer gives you a dialog that allows you to specify the name of your transformer, the category that you want to slot it into, and define whether it's always embedded into a workspace or whether it's linked to the network. And you can specify where you write that file out to, and that is then an FMX file. So a custom transformer, when it's exported, is a .fmx file. And they're available when you set up Fme to point to a particular network folder. They will then be available in a number of different installations of Fme, so you can share those around your organization. I'm not going to go into too much more detail about that. If you want to get in touch and find out more about that capability, then you're welcome to email us to pick up on that topic. And that's at fme@onespatial.com, so you can get in touch with us at any point through that email address. So what happens in this workflow is that we carry out a number of joins. So I'm just going to dive back into this view, and we're in this case using a feature merger to join based on a relationship between the code point data and in this case the NHS codes, and we're joining where the NHS code matches the feature in the lookup list with also an NHS code attribute name. So we've got that set up. And then any features that pipe out of this workflow are features that have a description attached to them now, rather than just having the code itself. And essentially the data will pipe its way all the way to the end, and it pops out the other end here, now having all of the different descriptive codes that were housed inside those source CSVs. The attribute expression renamer is a brand new transformer to Fme 2012 that allows me to force all of those attributes into uppercase. You can do a number of things like replace strings or carry out processes like put in suffixes, but it's a very useful transformer to be aware of, and that's new to Fme 2012. Something else that's new to Fme 2012 is the Fme Store. So you'll see that the Fme Store is available to you in your transformer gallery. You do need to have Fme 2012 installed to have access to the Fme Store. So that's an important point. So the latest version of Fme only. If you try and use Fme 2011 or prior to that to access the Fme Store, it will not work. It's a brand new construct in the latest version of Fme. You can see that there are a number of transformers available through here, and these are custom transformers that somebody else has created. Largely the ones that are available are ones that historically have been available on Fmepedia. To access them, you double-click the transformer, it connects to the web, navigates to the Fme Store, and downloads an FMX file. So that's a custom transformer that we've been talking about. And you can see that now I have something called the Smart Cleaner on my canvas, And this is a unique transformer created by somebody to do something specific that they think might be useful to you. So there's a description of what the Smart Cleaner gives you the capability of. So that's one capability highlighted there, and there's lots of transformers available to go and look at in the store. A transformer that we've made available, one of hopefully many, is the UK Postcode Validator, and you can see that that's on my canvas here. It's available to anybody, no matter where you bought your Fme license from, so you can go and download that transformer. You can either get it directly through Fme by just typing in UK, and you'll see that the transformer is available to you to download. If you've already downloaded it like I have, it doesn't have to make that connection, it just makes it available and drops it onto the canvas. If you would like to, you can also find out a little bit more about that by going to our website, and I just need to navigate my way back, and you can see that if I go to the benefits tab, you can see there's a little bit of detail about the UK Postcode Validator here, but you can also prove that it's something that is official by going to safe.com, and you'll see that if you go to the Fme Store on safe.com, you can see a little bit of detail about some of the other third-party utilities that have been made available, like the geocoding capability from DMTI and the reprojection capability from CZone that have been added in. So a few things to be aware of there. So what happens here is that we literally read our data in, we specify which attribute contains the postcode we want to test, and any valid postcodes are the ones that we allow to come out. And if it's invalid, we'll tell you why it's invalid and what the problem is, so you can see that there's a result and a result issue, and you can choose to throw that data away or fix it as a result of that process. I then do a little bit of attribute renaming, and right at the end I create the geometry. So take the X and Y coordinate and create a point on the map. So I've also got specified right at the end here a writer. So we're writing directly into the database, and this is an Oracle database. So I'm just going to choose to run this and write this out. I'm just going to pick one file, so we'll just process CV for the time being, although you could do all of the data in one go if you wanted to. What you can see is that on my reader I have it set up to merge feature type. So with an asterisk in there, I could read any number of CSVs with the same schema from that folder and process all of that data through in one go. And in this case I'm writing the data directly into Oracle and choosing to send that data out into the universal viewer so that you can see the results. If we just zoom in, this is the Cambridge area. I can zoom in and click on one of the postcodes, and you can see that for each of these postcodes now, rather than just having codes, you can see I also have the ward, the district, the county, and we've also got the NHS area that falls into, as well as the NHS region, because I've looked those up from the data that's supplied with that code point open data. So I can choose which fields I want to keep. What I've also done is loaded that data directly into my Oracle database, and you can see if I go to the format parameters, I have both created the table. If the table already exists, I've dropped it, but you can choose, if it doesn't exist, you can choose to truncate that table to basically remove any content that's in there. So there's a number of table level parameters that you can specify at this stage. And I've also created a spatial index, and that's a very important step in the workflow, because now I can quite easily go over to the next part of the process and read that data back from the database. So if we just prove that it's there, if I go over to the universal viewer and close this view and open up a connection to my Oracle database, we can specify a connection to my default database, and you can see that if you've added in some credentials previously, you can choose an option down here to specify a particular database as your default. And here is my code point open table, which I can open up and read the data directly back from Oracle. So the data in its complete entirety now, having been joined and created it in my Oracle database. And what I'd like to do is show you how I can work with that data once it's in there in a number of different ways. So now we've loaded the data, if I just dive over and open up a different workspace, I'll read the data in using a process here. And you can see, hopefully, from the screen that there's a number of different ways that you could do this. One tip I'll give you is that when you read data from a database, where possible, you want to try and get Fme to do as little work as possible. And this is the case with a lot of different data sets, actually. Quite a few data sets give you the ability to query data or issue a where clause or specify a spatial envelope. And the difference is that a lot of systems are optimized to carry out processes, like, for example, a database. It's optimized to carry out this kind of processing, to filter out content on a machine that's dedicated to it. If, however, you try to do it with Fme, what you're doing is you're pulling the data out of that remote repository, bringing it to your local machine, and carrying out an operation there. So what I'll do is show you one approach at the top here is if I add a reader, so if I go to the reader drop-down menu and add in an Oracle connection again, and I'm going to connect to the same table and basically define a feature type definition on the canvas. And put that onto my workflow. And I'm using a creator here to create a clipping box. So you can see that this set of bounding coordinates is the same that I've got listed on screen here. So I've created one polygon just here. So just to prove that, if we just disable this reader and pop a visualizer onto the workflow here, and just run that, we can see that in the universal viewer we just have a polygon. Nothing too interesting, but the creator has built that for us, and we're going to use that as our clipping geometry, so the thing that's going to clip our data out with. If I enable this reader, in the clipper we have the ability to specify a single clipper, and we don't want to merge any attributes onto the data, we just want to clip it out. And any point on the map that falls inside our feature will be essentially clipped out of our data. So we can run this process and process that through. So every feature comes through here and gets clipped against that bounding geometry, and only features that fall inside will get essentially processed out. Now, the downside to this process is, and you can see that that's an area that's smaller than what we had before, the downside to this process is that we have to read all the features into the workflow, and there's over 10,000 of them, and we then clip out over 3,000. The alternative mechanism is that we do the process on the database first. So if we just cut that out, and that process in this case took 9.3 seconds, and the peak memory usage was, well, I'm going to convert that to like 15 meg in that process. So if we move that down to here, when you're working with a small number of features, this isn't actually going to make a significant difference to the speed this process runs, but when you start working with large numbers, it does make a difference. If we go to our reader and we'll specify, you can see that on the database I have the ability to pass an aware clause, so I could go and get postcodes of a particular type and just read those back. I can also specify a bounding box, so I can type in here that I want to only read back 539000, and min y we want 252000, max x is 551, max y, and we'll go and pick up 264000. And you can parameterize these, so if you want the user to be able to enter these at runtime, then you can basically pop that up in this prompt and run window, so they have a list to key in at this point. You can even specify a clipping geometry if you want to. If I use the ability to clip to search envelope, we'll say that we want to do that. Now in this example it's not going to make a really significant difference because we're working with point geometry, but if we have roads, then if we didn't clip, then we would get a spatial interaction, which is basically an any interacts. So if we run this process now, we'll see that rather than the 10,000 features that we read back, we actually send a query to the database, and the database only sends us back the number of features that we actually want. If I move over to the viewer, you can see that we've got that data back. Now in practice, with the small number of features, as I say, the process isn't any faster, but when you're working with a much more significant data set, that is something to strongly consider as a way of reading or consuming your data. And you have a number of capabilities on the reader within the reader's parameters to pass in where clauses or individual SQL statements to run before your process is carried out. So have a look in some of your parameters on your readers. Some of the more involved Esri formats like file geodatabases have very similar capabilities, as well as some of the formats that you probably wouldn't think of. So Excel, for example, has the ability to read using a where clause. So it's a much more efficient process to make sure that you only pass into the workflow exactly what you actually want to work with. Okay. So when it comes down to consuming web services, we can use a number of different client tools to consume web services. If we go over to the view in the Universal Viewer and perhaps launch a tool like MapInfo or ArcGIS, you can go and connect to a number of different web services. So if I just go and open up, for example, a web map service, we'll dive into a web map service like the Openstreetmap web service, and we'll go and add that into MapInfo in British National Grid, and basically read that into our workflow here. And this will go and issue a WMS GET request to the service and bring back a raster image dynamically in the workflow. And when you zoom in, you can use MapInfo to basically poll that service again and bring back a different feature. So you'll see that as I zoom in, a number of different layers or features will be drawn and rendered on screen. So if I zoom in to a smaller detail, we'll get that data back there. And that will render on screen, but a little bit more detail. So we'll let that refresh. Whilst that's doing that, if I dive over to Fme, you can also see that Fme supports web services as well, so we can open up a WMS in a similar way. So we could say, let's go and read in the WMS and pick up the same set of layers that we are interested in. But this time we're going to have to specify a bounding box. So if I just pop this onto screen so I can see the values, we're just going to go and natively bring back the British National Grid data, and you can see that we can use a search envelope to specify that we want Cambridge, so 539 000. I think you get the idea, but I'm just going to quickly run through here. 551 000, and we're going to grab 264 000, and basically bring back just that small snippet of data into the viewer. And you could, if you wanted to, add a WMS or a WFS reader into Workbench and write a WMS to a raster image, so send that to a TIFF, and a WFS, a web feature service, send that out to a shapefile if you wanted to extract that bit of data. So it's sending the GET request over the web and dragging back that image of the area that we're interested in. And my web connection doesn't seem to be rocket lightning fast today, but hopefully that will refresh in a few moments. So Behind the scenes, the MapInfo connection has polled the service and brought that back. And hopefully, if I dive back to the viewer, here we go, it's downloading the data, and now we can see Cambridge as a raster in the universal viewer, over which we could overlay our data if we wanted to in the view there. So consuming web services, whether they're your own or a data set externally, is fine to do with Fme. Once you've got a web service, it could be a web service of one of your open data sets that you want to geocode to. You could carry out a process to take any asset data set and geocode it against that reference geography. So, for example, I have a workflow here that if we just maximize this a little bit, you can see that I have one reader that's reading in some CSV data. This is NHS data that I've downloaded through looking at data.gov, and I've downloaded all of the PCT locations, the SHA locations in the country, and downloaded those in CSV format. So in order to do that, I just navigated to find the NHS as the data.gov.uk publisher, and found the data that they're publishing and downloaded those data sets. And if we dive into one of these, you can see that TR contains some of the NHS data. And again, we've got that scenario where we have codes and we have postcodes this time round. So downloading and working with that data is very easy to do. What we've got here again is that merge capability, to merge on the input file name, so it doesn't matter how many CSVs we read in. We're extracting the CSV file name into an attribute, and then we're querying it. Because if I know for a fact that where the feature type attribute is PT, well, that contains primary care trust information, so I'm going to set a layer to be called primary care trust. So this is the concept of looking up a value that I alluded to earlier on, where we have an attribute value mapper to read in our data, and I can map the data to what it actually is using this workflow. The attribute renamer is an all-singing, all-dancing transformer in Fme 2012 that allows you to rename certain attributes, so column 1 is becoming the name. You can create new attributes, and you can set values in here. And a little known fact is that if you include a column reference in here and don't set any of the other values, that column will be deleted. So it's actually an attribute remover as well in this case. So that allows me to prepare my data and get it into a particular structure that I'm interested in, and run it through a validation routine that we've seen, and then I'm going to send it to the Sql Executor. So the Sql Executor is an inline process, so you'll notice that I don't have a database reader in this workflow, but this Sql Executor connects at runtime per feature to the database and sends a query. So this isn't necessarily the most efficient approach. This is just another approach, and it may suit you in a number of different scenarios. I make a connection to my database. I then go and send a SQL query. So if you're a database person and you know how to write queries, I can select all the columns from the table admin code point open where the postcode is equal to the value of an attribute that I'm passing in. So here, the postcode that's on the feature itself. And then I'm going to bring back from the database these attributes, so we can pull those back. So we're going to get that information back from our code point dataset and join them on to the NHS information that we've passed through. So you can see that if I very quickly run this, if I run the query, it'll go and for every feature that it reads out of the CSV, it issues a SQL query to the database, joins to the geometry, the code point geometry, and brings back that geometry feature. And then we'll get to see all of, for example, the PCT properties in the Cambridge area, because we've got some Cambridge code point data stored in the database. So the Sql Executor is a useful transformer to take a look at. I would suggest that when it comes to joining data to other locations, you look at the following transformers. There is a transformer called the joiner. There's one called the feature merger. There's also now an inline querier. And if you go and take a look at the inline querier's help, you'll see that there is a significant amount of information describing the different capabilities and efficiencies of several of these joining type transformers. And the Sql Executor is one that we're showing here in this workflow. So it gives us the ability to add that capability in. What I'm going to do very quickly is just add a writer into this workflow. I have to wait for it to finish before I can do that. So I'm actually going to stop it, add a writer into the workflow, choose the one that we want, and we're just going to write out to our location here, and we're just going to call this NHS and write that into a KMZ, a compressed KML file, and just write that out into our workflow. Okay, and we can then give that a layer name, so we'll call that NHS as well. Connect that up, and we're going to then copy attributes from a feature type. Now what I did previously to steal attributes is you'll notice that I've imported a feature type from the database, so it's hidden down here. This is the database table name. So all I'm using this for is to copy attributes from. So when you copy attributes from the feature type to another feature type, what that will do is to copy across basically the attributes and the data types that you have. So we can see that we have attributes and data types. Be careful not to copy just from a transformer, because if you do that, then you will not get the data types. So we can see here that if I dive across, right-click, copy attributes from feature type and choose the inputs. So this is our source data. We've now copied across the attributes and all the data types and appropriate width without having to process that through. Now, in true Blue Peter fashion, I'm going to open the containing folder because I don't have time to run that just now, and I'm hoping that I previously did it. So we'll just go and have a look and see if I did. Yep, thankfully I did. And you'll see here that we've basically got some NHS data. So if I go to the Primary Care Trust process there, we can just dive over to Google Earth and see that in here we now have the PCTs across the UK. So rather than just the Cambridge area, we can go on, click on the Milton Keynes PCT building and zoom our way all the way in to spot that. So that's data that's come from data.gov, geocoded against code point open data and then viewed over the top of Google Earth. And because all of that data has an open license, we don't have any intellectual property issues with Google Maps, but you could, of course, use a different backdrop for that process if you wanted to. So we've just got a couple of last things to finish up with, just to show you if you're okay to hang on. Conscious I've overrun a little bit from the process, from the workflow that I highlighted originally. So there's just a couple of other things to look at briefly. I wanted to mention a little bit more about 3D PDFs. So this will be a brief session just to show you capabilities with 3D PDF. And again, we can fire up a workspace whilst that's happening. And just to let you know that with Adobe, you have the ability to create layered PDFs with version 6 and above of Adobe Acrobat, and also version 7 above gives you 3D capabilities, and FME gives you the ability to work with the geospatial PDF and also 3D PDF writers in the FME product. From FME 2009 is the important part. Just had a question come in talking about whether people can access any of the demonstrations in this session. Yes, you can. You just need to drop us an email. As I mentioned before, if you contact us at fme@onespatial.com and ask for, in particular, if there's any sessions that you're in particular interested in, then we'll supply you with the workspaces so you can go ahead and manipulate them for your own use. These are demonstration workspaces, but we can make them available if you just drop us an email. So that question just in. Hopefully that answers that for you. Also a question about working with whether you can look at this demonstration after the event. If you've missed anything on here, we'll be posting this up on YouTube, so it will be available. So if you go and take a look at our OneSpatial group channel, and there'll be a URL for that at the end of the session. You can go and see a recording of this in a few days' time. So the process I want to do is show you working with some open data, and if I just close that down, those of you who have seen some of my presentations before will know that there are capabilities in Fme to create 3D data. And 3D can be written into PDF quite happily. So for example, if you go to Fmepedia, you can download this PDF. There's a very useful example on Fmepedia that shows you how to create this PDF directly with Fme. So all of this data has been passed through an Fme workspace, extruded, given 3D faces on the buildings, and you can see that there's a number of different layers in here that you can take a look at. This is available if you go and search for, and spell it Gavle, G-A-V-L-E. This is the Swedish town of Gävle, so G-A-V-L-E. If you have a look on fmepedia.com for that example, you'll see the workspace and the output example to show you how that can be created. I'm going to show you a variation on that with on the survey data. I've downloaded 1 to 250 thou color raster data from the open data set and landform panorama in DXF, and you can see that that's also available here. If I go and open that with the Fme Universal Viewer, you'll be able to see that the drawing exchange file is available for me to just open directly in Universal Viewer, and if I zoom in, we can go and see the different layers that we've got available in here. So there's our contour data, and the contours are explicitly located on the 201 layer, so we can see that. If we want to, we can extrude the Z value and take a look at the height using Fme as well, and you can see that that's essentially at the moment a 2D data set, but you can, when you read the data, read it in the third dimension. If we go over to a workflow that I've created that allows us to write out some data to 3D PDF. You'll see that this is a little bit more of an elaborate workflow. This allows us to read in the AutoCAD data and write out PDF data, but you'll notice that this process doesn't consume any raster data. And the raster data, the 1 to 250 thou data, is what I'm using to stamp over the top of my workflow. That data is actually read in at this top part of the process. This is an inline process, and this is quite a useful technique to be aware of. I'm using a creator transformer to create a trigger feature that goes and fetches a parameter that the user keyed in at runtime. So when you run this workspace, the user chooses the DXF that they would like to process. So they pick the one that they want, and when the user defines that, that determines the TIFF file that Fme goes and reads. So Fme allows me to go and find ny.tiff on that raster path that's defined there. So what my process does here is fetch the file path, the folder name, gets the strips out of it, the letters, and then concatenates that data to the folder with a backslash, and the TIFF I want with a .tiff on the end. And then the raster reader transformer reads in the TIFF that's required. So it only reads that one file rather than having to go and read every raster file in the whole folder. And the process basically clips out the little bit of the raster data that we need, and the result is that in this workflow we end up with a PDF that contains contour data, a triangular irregular network, so a face essentially onto which we can drape the 1 to 250 thou raster and turn that into the third dimension and write that into a layered 3D PDF and give access to that content. Now, sometimes when you're opening some of these more complex PDFs, it does take Adobe Reader a few moments just to get itself in order, but you can see here that if I turn off all the layers, we can see that we have some lakes, and we can click on these individual features and report back the attributes. So this is a lake that's at a height of 178 meters, and we can go and turn on the contours, turn off the lakes. When the contours are on, you'll see that we can go into 3D mode and take a look at the terrain and query the individual geometry, and we can of course turn on the raster surface, which has also been turned into a 3D terrain. All of that written with one workspace, consuming some data and writing it into PDF. So a little bit of information about how you can go about doing that. As I say, I can make this process available to us if you get in touch. Just to conclude, I wanted to very quickly highlight another capability through data.gov. So we'll be 3 or 4 minutes just to finish up. So if we go back to data.gov.uk, we can see there's some linked data available here. Linked data is an interesting topic, and you can go and take a look at some of the data that's available over here. And it's really all about giving a series of unique identifiers to link between different assets on different in different environments. So whether it's a, for example, you might have some bathing water data from the Environment Agency, and you want to know a bit of information about the individual beach that's related to, or the posts that mark out the delimiters for the area of that beach. So interesting information to go and navigate your way around. And Tim Berners-Lee, who was the inventor of the Internet, or is the inventor of the Internet, is somebody to go and look up and find out more about some of the things that he says about linked data. Somebody who's fairly involved with the UK Location Council is the guy that you can also see in front of you here, Alex Coley, who works for the Environment Agency, and he is doing a significant amount of work on linked data and looking at processes for making that available. The bathing water data is interesting to go and take a look at. If we just have a look at this bathing water site accessible via data.gov, you can see that you can go and look, for example, search for an individual beach and navigate your way around a web map, click on a location, and you can see in here that there are a series of maps with different backdrops that give you details about those sites, and find out more about those, and link to all of the different capabilities that are available for that data set. Go into the bathing water information, the individual sample data for each of those, and take a look at a lot of information related to that. What we can see is if we go and take a look at an Fme Workspace that I have in process here, so if I just dive down and open up a new workspace that I've got open elsewhere, and drop that into the workflow, you can see here that what I've got is I just steal a URL, is a URL to some bathing water information that I'll drop into my browser, and that's a classic error there. So let's just go and grab that URL we have in our reader and drop that across. There we go. So we've got some XML there. Now if I dive into this link and just change that to HTML, we get to see the same page as a web page. And we've got a number of ways of viewing it, as a CSV or as JSON or as an RDF, any number of variations. And we can consume a few of those with Fme. So I can add an XML reader into my workflow and read the data in and set the coordinate system to British National Grid, and then test the attributes based on whether it is the sample area for that bathing water data matches a high, minimum, or a fail. So I'm using an attribute filter to check a classification name there, and then I'm styling the data into an output. So if I just run this process and write it out, I'm consuming some XML directly from the web, joining to a number of different data sets on the web and writing that out. And you can see that if I then go and open the containing folder, we can open up the bathing water data directly in my workflow and go and take a look at an individual location and click on one of those features, and here we have all of the linked data. So if we now have the geography, if we want to go and find out more detail about, for example, the sample point and its reference details, we can go straight to it now. So linked data is an interesting topic. I wanted to bring it in here to show you how you can consume XML data or information that's out there on the web with your process and turn it into a flat file or write it into your database using Fme, and some techniques that are available in Fme Workbench. So I'd like to thank you all for joining this training session today. That's it for this Fme webinar. And there are a few training resources that you can get access to. If you go to onespatial.com/Fme, then you can access information about our services and also download Fme, contact us. You can get request evaluation licenses, and you can also find out more about the formal training sessions that we deliver, either classroom in your office or at our offices in Cambridge. You can obviously comment on this training or get in touch with about anything you've seen. The other place I would suggest you go to is fmepedia.safe.com, where there are some online resources, and that gives you access to a number of things like the YouTube channel, the Evangelist blog, and the Google group that allows you to chat to other Fme users. Just to conclude, this session will be available via our website or directly via YouTube, so youtube.com/onespatialgroup, or if you go to our Knowledge Center, you'll also see our videos are listed there, and this one will be up in the next few days. So sometime probably early next week, this video will be available for you to access. So thank you all very much for signing in today. And now my details are here. If you want to get in touch with me directly, you can do. Alternatively, of course, fme@onespatial.com is the email address to use.